Okay, circles, so many theorems. I'm not going to explain all the theorems again, but we can solve one or two questions, and there you can revise the theorems. You remember circles? You there? Huh? Revision we did, or the chapter only we did recently, no? So where you were there when I explained the chapter only, no? Hmm.
Anna, did you record circles?
Yeah, I would have.
So when can you post it?
I'll- Yeah, I'm working on all of them. I'll just note down whatever is important that I need to post. Just tell me.
Circles and cylinder, cone,
Okay.
similarity, tangents and intersecting chords. In trigonometry, heights and distances.
Trigonometry, heights and distance. Okay. What about the other subjects? Anything from that?
Computer and array.
Okay. Okay. All right. So here, let's look at this question. 26. So what all do we see over here in this question? You see this line is a diameter. So the property in a diameter is what? Any angle that's drawn from these 2 points, they'll be 90 degrees. Right? That theorem is called what? Angles in a semicircle is 90 degrees. Any other property you see over here? I see a parallel line. So when you see two parallel lines, what properties can you think of? All these corresponding, alternate interior, uh, all these properties of parallel lines can be used. Okay, so what do we have to find here? Find the angle AEB. AEB, this angle. Okay, anyone sees anything? Okay, so if you don't see anything, tell. See, if you can't figure out how to get this, you just start doing whatever you see. Like whatever theorems you see, just start applying all these properties. Eventually, you'll get it. Okay, so we saw so many properties. We saw the diameter one. So the any angle drawn from C and D will be 90 degree. Now from C, there's no line coming out. From D, there is one line coming out. That line is going to A. So let's draw one line from C to A also. And so this will be 90 degrees. Right. So now look at this triangle only ACD. We have 90, we have 25. We can find C. 90 plus 25, that's 115. Minus that from 180, that is 65. Now look, we got it actually. Did we? No, not yet, almost. DAB, this one? Yes. So this is 25, so this will also be 25. Alternate interior angles because of the parallel lines. Next what? Okay, see if I join BD, okay, I'm getting a cyclic quadrilateral here. ABCD is a cyclic quadrilateral. There's a property for cyclic quadrilateral that is opposite angles of a cyclic quadrilateral are supplementary. So look at angle A, that is 90 plus 25. And here, this whole thing is the angle for the cyclic quadrilateral. So when you add these two angles, you should get 180. That is 90 plus 25 plus 25 plus dash will be 180. Okay. 90 plus 25, that's the total angle here, plus 25 plus that missing value x will be 180. So that's how much? 90 plus 50, that's 140. So 180 minus 140 will be x. So that means x is 40 degree. Understand? Now this 40 and this will also be 40. See AB. From AB you're drawing an angle to D. From AB you're also subtending an angle to E. That property, remember? Equal angles in a segment are what? No. Angles subtended in the same segment are equal. What's the theorem? Angles in the same segment of a circle are equal. See, from AB, we're drawing subtending an angle to to D and also to E. So both the angles will be equal. Okay. So yeah, sometimes it takes time. So practice is more to get that. So we didn't need this 65, right? It was not needed. But we needed the 90. Right. So we had to draw this anyway. Okay, is everyone clear? Now, as you write, no, write the reasons, how you got this, how you got that. Okay, proper reasons, that's how you get your marks. So what all theorems we saw in this question? We saw angles in the semicircular 90 degree. Then we saw alternate interior angles 25, 25. Then angles in the same segment are equal 40 and 40. Angle sum property we used 65. We got cyclic quadrilateral. Opposite angles of a cyclic quadrilateral are supplementary. 5 theorems we used in this one question. Which theorem we did not use? This one. Remember, from AB, if you draw a line to angle to the center, subtend an angle to the center, how much will this angle be? Double of 40. So this would be 80. Okay, so that's one theorem we didn't use in this. Any other theorem that you remember that we did not use? I think from this chapter, these are all the theorems. Okay. Now, if you go to the next chapter, that is tangent, then you have some tangent properties also. Oh, in this, there are some chord properties also in the second part. Like two intersecting chords. Now, that's in the next chapter only. Yeah. In this chapter, these are all the theorems. In the B part, there are some properties that is like this. Remember this? If AB is the side of a square, then the angle it makes with the center will be 360 divided by 4. If EF is the side of a hexagon, then the angle it subtends to the center will be 360 divided by 6, because hexagon has 6 sides. If DC is the side of a pentagon, then the angle it makes to the center will be 360 divided by 5. Okay, so that is some not theorems, but some properties that are used in the B part. Okay. So I'll say that once again. Suppose this is the side of an octagon. Okay, then the angle it makes to the center will be what? 360 divided by 8. Okay, so like that we can get this angle. Next, can we get these two angles also here? Three 360 divided by 8 is 45. Okay, so we have this angle 45. Now, is there a way to get these two angles? We have only one angle. Can we find these two angles?
Isosceles triangle it is.
Yeah, it's an isosceles triangle because these two are the radii. So that means these unknown angles will be equal to each other.
Equal.
Take it as x And then we can use the angle sum property, which is 45 plus x is equal to 180. We can find x. Is that clear? So these type of questions are in the B part of this chapter. Okay, then the other properties from tangents. Let's go through those properties also, because mostly both these chapters will come together in one question. They don't give separately from circles, separately from tangents. Okay, so what are the properties in tangents? First property is this, that is a tangent and a line joining the tangent to the center will be perpendicular to each other. 90 degrees there. Then what is this property? From a point outside the circle, two tangents that are drawn will be equal in length. PA and PB will be equal in length. Then what is this theorem state? A line joining the two centers of both the circles will touch the point where the two circles meet each other. A line joining the two centers will pass through the point touching both the circles. Now this is if the two circles are external to each other. And this is if one circle is inside the other circle, internal. Here also the same property is used. If A and B are the centers, if we join a line, if I draw a line joining A and B, they will touch what? The point where the two circles meet each other. Okay. All right. And then you have these some more properties. So for this, if you draw two intersecting chords, okay, then you have this theorem, PA into PB. PA into PB is equal to PC into PD. This was, yeah, okay. Remember, some theorems are regarding angles, some theorems are regarding sides. In this question that we just did, all the theorems were using angles. None of them were using length of chords, length of sides or anything. Okay. But here, whatever we saw, like the first theorem was what? This was regarding angles, not about the side. The next theorem was regarding side, the length of the sides. The length of these two sides, PA and PB will be equal. This was nothing related to side or angle. But yeah, the tangent. See, the tangent that's drawn at this point will be perpendicular to this line joining the two sides. So that's 90 degree. Then this theorem has nothing to do with angles. It's just the length of those chords. Okay, here these are also two chords, but they're intersecting externally. They're meeting at a point outside. We call this line as secant. Right, it's touching 2 points in the circle. So here what we have, same like the previous one, from the point where they're intersecting. See here where is they're intersecting is P. So that's why PA into PB is equal to PC into PD. Here also we apply the same thing. P is the point that they're intersecting. So PB into PA is equal to PD into PC. And then how many more theorems? Two more theorems. Okay. So this theorem is between a tangent and a chord. Right? The tangent is PQ, the chord is say PA. So what does this theorem state? Okay, let's look at the set. Okay, let me draw it. So what the theorem says is the angle between a tangent and a chord, say this angle here, will be equal to the angle in the alternate segment. That means from this chord, if you subtend an angle on the other segment, that is this point C, say this angle, these two angles will be equal. Okay. you can look at it at the other way, like this double angle. Okay. So the angle between the tangent and the chord on the left side, that is this angle here, will be equal to the angle made by subtended from the same 2 points A and B on the alternate segment, that is on D. Okay. So this theorem is sometimes a little hard to see, but if you see a tangent and any chord drawn from that point of where the tangent meets the circle, you look for this theorem. Okay, and this theorem is what? We have not seen this. If a chord and a tangent intersect externally, okay, so that means, see, this is the secant and this side is a tangent. Okay, so if there's a secant and a tangent that are meeting externally, then PA into PB is equal to PT square. PA into PB is equal to PT into PT. You understand? From the point external. It's same like the other theorem only for two chords. PA into PB is equal to PT into PT. What if there was another this thing like this? Another secant like this, say CD. So now what is that property? From PA into PB will be equal to what? PD into PC. Okay. All right. So these are all the theorems from this chapter. What are any other chapters remaining?
No, sir. The 20 chapter is not there, no, for this test.
No, 20 is the next test. Last one is what? Construction. Okay, construction we have already
Construction.
spoken about it. Okay,
Yes, sir.
so I mean, yeah, practice. You have to do that much only. Okay, practice as many questions as you can. So we'll end with this. So till evening, you'll practice all these chapters. Which all chapters? Can't hear you. 15 to 19. What is 15 chapter? Similarity, loci, circles, tangents, constructions.
Intersecting chords.
What is that? A chapter?
Tangents only.
Intersecting chords. Yeah.